So hello students. Today we'll start our new unit number 2, which is named as infrastructure. So the first topic number 1 is introduction to infrastructures and transportation. So at first, the different types of infrastructure. Under infrastructure, the first one is habitat. In an ecology, a habitat is the type of natural environment in which a particular species of organism lives. It is characterized by both physical and biological features. A species' habitat is those places where it can find food, shelter, protection, and mates for reproduction. The physical factors are, for example, soil, moisture, range of temperature, and light intensity, as well as biotic factors such as the availability of food and the presence or absence of predators. Every organism has certain habitat needs for the conditions in which it will thrive, but some are tolerant of wide variations while others are very specific in their requirements. A habitat is not necessarily a geographical area. It can be the interior of a stem, a rotten log, a rock, or a clump of moss, and for a parasitic organism, it is the body of its host, part of the host's body, such as the digestive tract, or a single cell within the host's body. Habitat types include polar, temperate, subtropical, and tropical. The terrestrial vegetation type may be forest, steppe, grassland, semi-arid, or desert. Freshwater habitats include marshes, streams, rivers, lakes, and ponds, and marine habitats include salt marshes. The coast, the intertidal zone, estuaries, reefs, bays, the open sea, the seabed, deep water, and submarine vents. Habitats change over time. This may be due to a violent event such as the eruption of a volcano, an earthquake, a tsunami, a wildfire, or a change in oceanic currents. or the change may be more gradual over millennia with alterations in the climate as ice sheets and glaciers advance and retreat, and as different weather patterns bring changes of precipitation and solar radiation. Other changes come as a direct result of human activities, deforestation, the plowing of ancient grasslands, the diversion and damming of rivers, the draining of marshland, and the dredging of the seabed. The introduction of alien species can have a devastating effect on native wildlife through increased predation, through competition for resources, or through the introduction of pests and diseases for which the native species have no immunity. Next one, megacities. A megacity is a very large city metropolitan area, typically with a population of more than 10 million people. Precise definitions vary. The United Nations Department of Economic and Social Affairs in its 2014 World Urbanization Prospects reports counted urban agglomerations having over 10 million inhabitants. A University of Bonn report held that they are usually defined as metropolitan areas with a total population of 10 million or more people. Others list cities satisfying criteria of either 5 or 8 million and also have a population density of 2,000 per square kilometer. A megacity can be a single metropolitan area or two or more metropolitan areas that converge due to close proximity. The terms conurbation, metropolis, and metroplex are also applied to the latter. As of 2017, there are 47 megacities in existence. Most of these urban agglomerations are in China and other countries of Asia. The largest are the metropolitan areas of Tokyo, Shanghai, and Jakarta, each having over 30 million inhabitants. China alone has 15 megacities, India has 5, Japan has 3. Other countries with multiple megacities include the United States, Brazil, and Pakistan, each with 2. African megacities are also present in Nigeria, Egypt, and the DRC. Smart cities. A smart city is an urban area that uses different types of electronic Internet of Things IoT sensors to collect data and then use signals gained from that data to manage its resources and services efficiently. This includes data collected from citizens' devices and assets that is processed and analyzed to monitor and manage traffic and transportation systems, power plants, utilities, water supply networks, waste management, crime detection, information systems, schools, libraries, hospitals, and other community services. In the approach of the Smart Cities mission, the objective is to promote cities that provide core infrastructure and give a decent quality of life to its citizens, a clean and sustainable environment, and application of smart solutions. The focus is on sustainable and inclusive development, and the idea is to look at compact areas, create a replicable model which will act like a lighthouse to other aspiring cities. The Smart Cities mission of the government is a bold new initiative. It is meant to set examples that can be replicated both within and outside the smart city. Catalyzing the creation of similar smart cities in various regions and parts of the country, the core infrastructure elements in a smart city would include adequate water supply, assured electricity supply, sanitation, including solid waste management, efficient urban mobility and public transport, affordable housing, especially for the poor, robust IT connectivity and digitalization, good governance, especially e-governance and citizen participation, sustainable environment. Number 9, safety and security of citizens, particularly women, children, and elderly, and health and education. The next topic is transportation. The first one is roads. Road transport or road transportation is the type of transport by using roads. Transport on roads can be roughly grouped into the transportation of goods and transportation of people. In many countries, licensing requirements and safety regulations ensure a separation of the two industries. Movement along roads may be by bike or automobile, truck, or by animals such as horse or oxen. Standard networks of roads were adopted by Romans, Persians, Aztec, and other early empires and may be regarded as a feature of empires. Cargo may be transported by trucking companies, while passengers may be transported via mass transit. Commonly defined features of modern roads include defined lanes and signage. Various classes of road exist, from two-lane local roads with at grade intersections to controlled access highways with all cross-traffic grades separated. The nature of road transportation of goods depends on, apart from the degree of development of the local infrastructure, on the distance the goods are transported by road, the weight and volume of an individual shipment, and the type of goods transported. For short distances and light, small shipments, a van or pickup truck may be used. For large shipments, even if less than a full truckload, a truck is more appropriate. In some countries, cargo is transported by road in horse-drawn carriages, donkey carts, or other non-motorized mode. Delivery service are sometimes considered a separate category from cargo transport. In many places, fast food is transported on roads by various types of vehicles. For inner-city delivery of small packages and documents, bike couriers are quite common. People are transported on roads. Special modes of individual transport by road, such as cycle, rickshaws, may also be locally available. There are also specialist modes of road transport for particular situations, such as ambulances. Next, railways. Rail transport or train transport is a means of transferring passengers and goods on wheeled vehicles running on rails, which are located on tracks. In contrast to road transport, where vehicles run on a prepared flat surface, rail vehicles or rolling stock are directionally guided by the tracks on which they run. Tracks usually consist of steel rails installed on ties, that is, sleepers set in ballast on which the rolling stock, usually fitted with metal wheels, moves. Other variations are also possible, such as slab track. This is where the rails are fastened to a concrete foundation resting on a prepared subsurface. Rolling stock in a rail transport system generally encounters low frictional resistance than rubber-tired road vehicles, so passenger and freight cars, that is, carriages and wagons, can be coupled into longer trains. The operation is carried out by a railway company providing transport between train stations or freight customer facilities. Power is provided by locomotives, which either draw electric power from a railway electrification system or produce their own power, usually by diesel engines. Most tracks are accompanied by a signaling system. Railways are a safe land transport system when compared to other forms of transport. Railway transport is capable of high levels of passenger and cargo utilization and energy efficiency, but is often less flexible and more capital intensive than road transport when lower traffic levels are considered. Next, metros, that is rapid transit or mass rapid transit, in short MRT, is also known as heavy rail, metro, subway, tube, U-Bahn, or underground. It is a type of high-capacity public transport generally found in urban areas. Unlike buses or trams, rapid transit systems are electric railways that operate on an exclusive right-of-way which cannot be accessed by pedestrians or other vehicles of any sort, and which is often grade separated in tunnels or in elevated railways. Modern service on rapid transit systems are provided on designated lines between stations, typically using electric multiple units on rail tracks, although some systems use guided rubber tires, magnetic levitation, or monorail. The stations typically have higher platforms without steps inside the trains, requiring custom-made trains in order to minimize gaps between train and platform. They are typically integrated with other public transport and often operated by the same public transport authorities. However, some rapid transit systems have at great intersections between a rapid transit line and a road or between two rapid transit lines. So this is your weekly assignment number 3. You have to write about the smart cities of India and you have to explain in details about the ancient marvels in civil engineering. Though I have taught you about the ancient marvels in civil engineering, that was just a brief explanation, but you have to write it in detail. The last date of submission is mentioned here. We'll go through 2 to 3 videos now. Kindly have a look at it. Also drop your name, enrollment ID and section in the chat box for your attendance. Thank you.
Foot-long circular tunnel with a 17-mile circumference. It is the largest and highest energy particle accelerator. It was built in 2008 to answer many basic questions of science and the universe and to further develop technologies such as medical imaging, electronics, radiation processing, new manufacturing processes, and more. At number 5 is Palm Islands in Dubai. Perhaps one of the more impressive innovative engineering feats, the Palm Islands are located off the coast of the United Arab Emirates in the Persian Gulf near Dubai. Known as the largest man-made set of islands, the project, which is constructed by Nakhil Properties, a land developer in UAE, began in 2001 with the first of the three islands, Palm Jumeirah. It is the world's largest artificial island. At number 4 is the BAILONG elevator in China. The BAILONG elevator is the highest and heaviest outdoor elevator in the world. It is 1,070 feet high and consists of three double-story glass elevators, also known as 100 Dragon elevators. The sightseeing elevator, which takes 2 minutes to ride from the base to the top, can carry 50 people in one trip, with a total of 18,000 people daily. Construction of the elevator began in October 1999 and was finished in 2002 for public use. It is the world's highest and heaviest outdoor elevator. At number 3 is the National Stadium, also known as the Bird's Nest in China. Nicknamed the Bird's Nest for its intricate shape and lattice-like design, this astonishing structure looks more like a public work of art than an Olympic stadium. Designed by Swiss architects Jacques Herzog and Pierre de Meuron, the Bird's Nest was built for the 2008 Olympic Games and Paralympics and seats 80,000 people. The elaborate design incorporates Chinese symbols and mythology. Consisting of about 26 miles of unwrapped steel, the stadium is made up of two independent frames that are set 50 feet apart, an inner concrete red bowl for seating, and an outer steel frame weighing 42,000 tons. The world's largest steel structure is one of the most energy efficient and environmentally friendly stadiums in the world. At number 2 is the Venice Tide Barrier project in Italy. After 40 years of debating how to protect Venice from floods and to keep it from sinking further, the Venice Tide Barrier project was instigated in 2003. This innovative engineering feat, which consists of 78 rotating gates, is designed to keep the seawater from entering the Venetian lagoon if high tides and storms are in the forecast. The gates, each 6,500 square feet, are large metal boxes filled with water that rest at the bottom of the sea. It is the world's largest flood prevention project. And at number 1 is Millau Viaduct in France. With its spectacular silhouette lines, somewhat reminiscent of the St. Louis Gateway Arc, the Millau Viaduct, which spans across the valley of the river Tarn near Millau in southern France, is still date the most impressive engineering ventures in the world. The bridge's highest tower soars to 1,125 feet, making it the tallest cable-stayed road bridge in the world. The Millau Viaduct, completed in December 2004, was constructed to alleviate congested traffic on the route from Paris to Barcelona during the summer vacation months. This bridge took only 3 years to complete and carried several engineering risks. Beyond any doubt, all these astounding, modern, man-made marvels can make anyone gasp in awe. With Vijay Sonkhya, Zeba Varsia for NMTV News.
There is no wonder why foreigners' visit to India increases every day. India, well known for cultural heritage and massive wonders. India is filled with splendid and mind-blowing architectural marvels. There are no doubt these architectural engineering excellences and brilliance of our ancients will make you question our modern knowledge of architecture. The ages of these buildings dates back around 1,000 years and more, and still stands strong without failing to delight our eyes. Here we have listed top 10 exclusive ancient engineering marvels of India. Number 1. The Thanjavur Brihadiswarar Temple. This 1,000-year-old temple's engineering mystery hasn't been solved till date. Built by Raja Chola, the entire process of construction of the temple is a mystery to archaeologists. It is not only one of the tallest temples in India, but also the first complete granite temple of the world. Take a look at some interesting facts. Archaeologists have no clue from where the builders get such massive chunks of granite for construction. There's no granite quarry within 100 kilometers radius of the temple. Advanced techniques of epic proportions were used to get the granite stones to the construction site. A huge 81.3-ton capstone lies at the top of the temple tower. For ages, scientists couldn't solve how such a huge stone could be placed at such heights. Later, remains of ramp with gentle 6-degree slope, pointing towards the top of the temple was found. The ramp began 1 mile away from the temple and gradually intersected with the top of the tower 216 feet in the air. Number 2. Yaganti Temple, Andhra Pradesh. Sri Yaganti Uma Maheswara Temple or Yaganti is a temple dedicated to Lord Shiva in Kurnool, Andhra Pradesh. There's a small pond of water on the temple premises, known as Pushkarini. Water flows into this Pushkarini from the bottom of a hill through the mouth of Nandi. No one knows how the water reaches the pond throughout the year. Number 3. Kumbalgarh Fort. Have you heard of the Great Wall of China? Of course, you might have. What if I ask you of the second longest wall in the world after the Great Wall of China? Confused? Don't know? Won't you be surprised if I say it's present in the Indian state of Rajasthan? Shocked? Exactly what I was when I heard that Kumbalgarh Fort in Rajasthan has got the second largest wall in the world. Built on a hilltop 3,600 feet above sea level on the Aravalli Range, the fort of Kumbalgarh has perimeter walls that extend 36 kilometers, making it one of the longest walls in the world. The frontal walls are 15 feet thick. Kumbalgarh has 7 fortified gateways. There are over 360 temples within the fort, 300 ancient Jain and the rest Hindu. From the palace top, it is possible to see kilometers into the Aravalli Range. The fort was never ever conquered in battle due to its walls and camouflage. However, the Mughals did manage to capture it briefly when they poisoned the water supply of the fort. Number 4. Meenakshi Amman Temple, Madurai. One of the largest temples in India, the Meenakshi Amman Temple has 12 massive gates, with biggest gates situated on the outer walls. These are known as Gopuram and are a great spectacle. There is a tank inside the premises, besides a hall, known as the Hall of Thousand Pillars, the amazing sculpting on which is beyond compare. Other halls too are adorned with beautiful figures, designs and carvings, and are unique from each other. The original temple was reconstructed in the 17th century by the first Nayak king of Madurai, Vishwanath Nayak, after it was damaged during Islamic invasion of the region. The temple, along with its complex, now spreads in an expansive 45 acres space and is a major spot for Hindu devotees and cultural admirers. Number 5. Kailasa Temple at Ellora Caves, Maharashtra. It is one of the largest rock-cut monastery temple cave complexes in the world, and a UNESCO World Heritage Site featuring Buddhist, Hindu and Jain monuments and artwork dating from the 600 to 1000 CE period. It features the largest single monolithic rock excavation in the world, the Kailasa Temple, a chariot-shaped monument dedicated to Shiva. The Kailasa Temple excavation also features the gods, goddesses, and mythologies found in Vaishnavism, Shaktism, as well as relief panels summarizing the 2 major Hindu epics.